welcome to the third video. In this video, we'll be doing a deposit, and if there's time, we'll do a withdrawal. If not, I make a separate video for that. So in this contract called management contract, we'll be depositing this token into it, and I'm going to show you how. So let's copy the base stuff that we need, which is just all this. Back in the day, when you were getting tested for like a Solidity job, the number one thing they would ask you to do is they would ask you to import an ERC20 into your project, and then obviously like do something like something like a deposit or a withdrawal with it. Then the barrier to entry was so high, so this task was considered complex. But sadly, today, this task is so basic. It's the most basic thing ever. It's like water. If you can't do this, you can't do anything. So, what are we going to be doing? Actually, no, I shouldn't be importing an ERC20 token like this. Yes, I'm going to show you how to. So that's how to import from OpenZeppelin. But now we want to import from our project called token. So I'm going to do import. I'm going to say this, it's quotes, and then I'm going to say, actually, let me do that again. What do I want to import? Token.sol. I'm importing token.sol. This is what I'm importing. First thing first is, in order for me to import token.sol, I need to know some things about it. One is I need to know, so this is token. I'm gonna just call it token. Yeah. So this is this big token. Okay, so I don't confuse you. This big token is this thing I just imported, and my token is what I'm going to call it within my project. I'm not sure I can make it public. I'll probably try that. Let me see if I can. Huh, what do you know? I never do this, but let's see what happens. If you notice, I do that a lot. I always say, let's see what happens, because experimenting is how you learn stuff, right? Like you try to break stuff by trying stuff out. So, management contracts, if I deploy it right now, it can't do anything. All you would see is this. But I like trying stuff out, so let's deploy stuff. So first of all, let's deploy token. Initial supply 500, done. Let's come to management contract. It's not going to do anything. Let's deploy it. The only thing it has is called my token. My token does nothing. It's just an empty address. Okay, so we need to assign this address to my token. So how do we do that? I think that what I want to do is I want to define my token at the time of deployment. So I'm going to say constructor, I want you to take an address for my token, and I want you to assign my token to become I want to actually try something. So typically, I think this is usually this is usually how I would do it. Yes, this is usually how I would do it. So what am I doing here? I'm assigning my token to, and this is unique, by the way. Like this, you won't see me do this very often. What I'm doing is I'm taking in the address for this token, and it's kind of like I'm making a token meat pie, and I'm inserting it into like a pie that has a shell, like the dough around it, and the shell is token, so that I can access my token. So let's deploy this new contract, this new management contract, using this. My token. This time around, my token has the same address as this. So we want to confirm some things. Um, we know here that the token supply is this, the symbol is this, the name is this. Let's confirm that we can actually see those things. All right. So let's write the function called get total supply, and if it takes nothing, and then which is callable function, so it's external. Let's write the view function because we're not changing states. Here we're returning uint 256. So we are going to return my token dot ha. Now this is where it gets interesting. Remember that I told you that we imported the token, right? And then it was showing you the address. But the moment I did my token dot, instantly it shows you all the functions available to the token, because that's what we imported. So what am I going to do? I am going to say let's import total supply. Why is there two of them? Let's import total supply. I also want to import, and I'm not going to use this a lot, get user balance. Actually, I'm going to do this, but I don't want to get ahead of myself. Let's do the ones that you can see. Function get symbol external view returns. Now what do I return? I return a string type. I think we've handled this before. String type has to be in memory. Okay, so note that. Symbol, yeah. And the last one, let's just copy this because it's going to be very similar. This one calls get now name, but this time want to return name. Boom. Yeah. So same token. We're going to deploy a new management contract. Okay. So let's just copy this address because we're going to use it. Boom. Here we go. And I don't have to pass this in every time. I can actually hard code it, and I think I might end up doing that. And I'll show you how in the next, after this deployment. So now I have my token and I have the three functions I created. My token, same address, get name. When I call get name, it's going to call the name of this contract. Gold, symbol, GLD. You can see. So we've been able to access the state of another contract from this contract, all by passing in, this contract and wrapping it within this object called token. So because I don't want to, every time I'm going to be deploying this contract a lot, I don't want to keep copying and pasting, copying and pasting. I'm going to hard code the address. So let me do something very, very cool. I'm going to say address. So usually when you're defining something Solidity, you specify the type first, you specify the visibility next. Then you can also specify if you never want the value to change. I don't want the values to change, so I'm going to call it a constant, and I'm going to give it a name. I'm going to say token address. Now I'm using a big caps states to write this because that's the convention for things that you do not want to change. These are constant things, right? And I'm going to clean this up because I'm just gonna just say, just do this for me, that's all. Now it's saying, oh yeah, I kind of need you to pass something in here because you don't have my token anymore. So we're gonna pass in token address instead. Yeah. So I'm gonna put this in. Boom. Now I'm gonna close this. Now I can deploy without having to pass in the token address all the time. And to prove to you that it works, first thing, gold, supply, contract, as you can see, snow. So yeah, we've successfully been able to, first of all, access the state of the contract. Now, when we're doing the deposit, like I promised, we are going to be changing the state, But before we deposit, I want us to do something. This is a contract that deployed, right? Remember that when we deployed this contract, we said that the balance of the person who deploys it should have all, like, the total supply. So I'm going to copy this address. And then I'm going to come here and I'm going to check the balance of this contract. Can you see? It has 500. So currently this contract is, think of it like an address book or like a ledger. And in that ledger, it says this address has 500,000. Now, this second address has 0. Nothing. So what I want to do now is I want to deposit some tokens from the first address into the contract. What's the best way to show this? Oh dear, I have messages. I figured. Let's come to management contract. Okay. We come here. So I'm going to create a function called deposit. This is obviously a different type of function. We don't need all of this anymore. But maybe what I should do is, let me just call this deposit, right? So when you want to deposit, what's important? You need to know how much you want to deposit, yeah? So this is, let's call this amount to deposit. And we can do external. So it's an external function, right? Now, I need to say something, and this is very important. Um, Let me see if I can show you how approve ERC20 tokens works. So I'm going to come here, see if I can show you something. So the ERC20 has a function called an approve. What this does is this method empowers a token holder to authorize a designated smart contract to spend a predefined quantity of tokens from their balance. Does this sound familiar? Sounds like what we're about to do. Um, this contract called management contract is going to be receiving tokens, but it's not going to be receiving any kind of tokens. It's going to be receiving the tokens that belongs to a particular user. So in order for you to do that deposit, you first need to approve this contract to receive it. The question is, where do you do the approval? I'm going to show it to you now. So if we come here, you can see this function called approve. You the spender, usually you're going to approve that, oh, I want this contract to spend my tokens. Now, I'm going to try to deposit without approve, and you're going to see that it's going to fail. So, in order for you to actually deposit, we make use of a different function. We use this function called transfer from. Now, transfer from is a function that I'll show you. My token dot transfer from. It's a function that has a from value, a to value, and a value. We know that value is amount to deposit, so we substitute this in. From and to. The from, this is the person who is requesting the deposit. So as you probably know, it's going to be our message or sender. The to address is the contract address. So we're going to say this is how you get the contract address, and then you say this. So this contract address and this. So deposit. So we're saying we're depositing my token transfer from this. Obviously, so that you can see what I'm doing. We talked about events previously. So let's say events. Let's call it deposited. And if I recall how to event deposited, it's crazy. I forgot how to do events. I do this stuff every day and I forget. It's ridiculous. But yeah, that's what happens when you're thinking about different things. Yes, just wrap it in. You know, sometimes you work on different languages and after a while you forget. So, what's this event going to do? Event should take address. You might ask what's the meaning of index. Index means that when I'm searching my events in the future, programmatically, you want to be able to search by address. So let's call this depositor. And let's say deposited. Good. So we emit our event here called deposited. The depositor is the person who calls the contract. The amount is amount to deposit. Boom. So this. But I mean, obviously that's not going to be enough. Within our contract as well, we need to, if this person is going to deposit, we kind of need a record, right? This this is for off-chain stuff. We need an on-chain way to know, you know, that so and so person has deposited. So we use our favorite tool called the mapping. The mapping, let's create something called a mapping of addresses to amounts. Okay. Previously, I labeled this, but I'm not. You can do it without labeling, which is the more common way. Um, Public user balances. All right. Some people just call it balances. So what are we going to be doing here? So the moment we call deposits, we want to say I'm going to do this. You're going to understand why. User balances for message.sender, we want to increment it by that amount called amount deposit. And then we're going to do a transfer to to this contract, and then we're going to emit this. Obviously, I want certain things. What's the condition? I want my amount deposit to be greater than 0. It's going to be invalid amount. Okay. All right. We're going to try to deposit, and like I mentioned before, this is going to fail because we're going to call deposit before we call approve. So let's come here, close this, deploy a fresh management contract. We have our function called deposit. Now remember we had 500 before, so this time around let's deposit 5 out of it. Okay. And yeah, let's see. It failed just like I told you it would. It said revert. The reason, insufficient allowance. You need to, this error is going to be, you're going to meet this error a lot. So kind of understand why it happens. It says the address may not, that address may be allowed to operate on the tokens without being the owner. So basically it's saying that you're trying to get this contract to spend my tokens, but you've not given it any approval, which is literally what I was talking about here. So we need to then, give it an approval. Just watch what happens when I do that. So remember it's 5 here. Okay. So let's copy the address of this contract. And let's come to token. We're going to say this contract 2x blah 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 blah, which is this. I want you to spend 5 of my tokens. Remember 5 is not 5. 5 is we want to spend 5. This 5, the big one, not the small one. So we want to spend 5. So I'm going to approve this. So before I do that, I want to show you something. Now, this is allowance. This was what tripped the error. Let's check and see if I have given the contract any allowance. The owner of the token is this person. No, not transfer. The spender of the token is this address. Can you see the allowance is 0? So it means my spender has 0 allowance. Let's increment it by calling approve. When I call approve, check this. This goes up. So that means my contract can now spend up until this amount. Now this is very important because without this, a contract can pull an infinite amount of your tokens from your wallet. Um, Let me show you something. So this, remember that I told you that this is the owner of the tokens, yeah? This is the person's balance. Can you see? Yeah. Okay, cool. So now I am going to come back to deposits. Let's copy the number that way, the big number, and then we're going to try to deposit. You're going to see this time that it works. So what do we have here? The amount to deposit done. It triggered several events: the transfer event and the deposited event. This is our deposited event. What did we deposit? Who deposited this person? How much? This amount. Um, Now, if I come to the balance of this guy, we've reduced his 500 balance by 5. So what do we expect it to be now? 455. Oh, we missed one of our zeros. Oh, sorry, not 455. That was 50. 495. So you can see the balance is now 495. That's because this allowance has been spent. So you can see the allowance has gone back to zero because everything has been taken. So if the contract tries to deposit again, it's going to fail. Call deposit again. Same error because the allowance has been spent. So it's like you give your son an allowance, yeah, and he spends the allowance. Once you spend it, it's gone, yeah. So the balance is still the same, still 495. Now, where did the 5 go? It went into the contract. So it assigned the value of 5 tokens to the contract. So if we then copy the contract address and we'll come to the balance and we check it, see, the contract now has it. So technically, what that means is we moved 5 tokens from the owner to the contract. So the owner's balance is down -5. The contract's balance is up +5. So we just actually did our first deposit contract. Now remember that the capstone project of this thing is making something called a DeFi bank, which allows you to obviously deposit, borrow, lend, and all that jazz. We have just implemented a function that we're going to use in the future, which is deposit. So this is a very important function. It's very, very important. It's one of the most important functions you would probably write in all of Solidity. It's very small, but yeah, you can always add stuff to it depending on your business logic. But the deposit function, very important function. It goes without saying. So remember now that we have 5 tokens in this contract, but we don't have a way to withdraw from the contract, which takes us to our next video. In our next video, we're going to write a withdrawal function. But, and the big but is, the 5 tokens that we have deposited in here, they are gone forever. Why is that? Because we deposited 5 tokens into this contract, but there is no way to take the tokens back. So the contracts, the 5 tokens are gone forever we can't retrieve it. And this is why you should be very careful in Web3 that when you interact with contracts that are written by other people, you know? Um, yeah. Then I was going to show you guys something about decimals. Um, let me see. So this is USDT, right? If we come to the contract, you can actually see what the USDT contract looks like. It's here, you know, and all that. Apparently allows you to blacklist some people, but it's like if you legally acquire ERC20 tokens of USDT, it can actually block you out. You know, get blacklist status and stuff. Remember all those functions we were talking about? Balance of total supply, the name, it has everything. It also has decimals. Now, you can see that next to the function, you can see some like hexadecimal code. What this hexadecimal code is it's actually like it takes something called like so it hashes the function name, and it takes the first 4 bytes of the hash. I know you already know what a hash is now, so you know. Yeah, so the USDT contract has 6 decimals. And that's what I wanted to show you. The the BNB contract has 18 decimals. The USDC contract has 6 decimals. So I think when we're doing our bank, we're going to use 6 decimals instead of 18 decimals. Generally, I like 18 decimals because of precision, but it seems like these guys use 6 decimals, so we might have to change our decimals in the future to 6. Yeah, so we have our token, we have our management contract. Now we are going to move to the next function, which is withdraw. Okay, and yeah, let's do that.